Hello and welcome back to the Punny Math Teacher. Today is a big day. We're starting our factoring. So this is going to take us 2 videos and I might do a bonus one, but it's a lot of just extra practice and practice and practice. Most likely we'll just be doing 2 videos and then a bunch of practice in your classroom. So making sure you're using all the extra resources on my website and then pause and make sure you're using twice this video's length to actually make sure you understand each step and why it works. All right, factoring is a lot of a mental exercise and it's going to help you really well with your multiplication facts, which is awesome. So to solve quadratics, we have 4 different tools. Graphing, you already know. Square root property, you already know. And I've hinted at quadratic formula. But factoring is what's coming next. So we're going to take 2 videos to learn how to factor, and then we will learn how to solve by factoring. So that's why it's one of those bottom objectives of just like, hey, FYI, this is something you're going to learn, but it's going to be so you can solve quadratics. And it is a huge thing, and it's awesome when something can fit the pattern for factoring. So we're going to start with greatest common factor and factoring that out. Then we'll work with grouping and that strategy. And then we're going to solve quadratics by factoring. So those are the 2 main ones. There is a common sense or logic. I call it logic. If you can see it and the more practice you get, the faster you can get with factoring. But grouping will always work as well. So let's go on to page 49. Move my gray marker. 49. Okay, so greatest common factor. Let's do purple. So a factor is a number, or we're going to be working with it where it's an algebraic expression that divides another number or another algebraic expression evenly. And I'm going to box that word divides, okay? So greatest common factor is the largest. Common means they all have it in the same, and a factor is what this is, okay? So if I have 3x squared, notice that this is really 3 multiplied by an x multiplied by another x, correct? And I'm using those dots to represent multiplication, but you could use parentheses. All right, and 15x to the 4th would be a 3 multiplied by a 5 multiplied by 4 x's. So the 3 and the 5 are the prime factors that make up 15. 3 is already prime, so it's its own prime factor. I'm not including 1s because 1 is not prime, and you can't stop. Because if you add 1s, you're going to do 1 times 1 times 1 times 1, and it's going to go on forever. So we don't put the 1s in, we just have the 3 and the 5, or if it's prime already, you just leave the 3. Okay, so together, their GCF, their greatest common factor is... well, let's see. Okay, they both have an x in common, they both have another x in common, and they both have a 3 in common. That's the max that they have in common. So their GCF will be 3x squared. And this is because they both have it. They both have 3x times x, and it is the largest thing, or expression, or number, or factor, amount of factors they both have. So I can't just let it sit at x, or x squared, or 3x. I have to make it a 3x squared because that is the largest amount of factors that they have in common. So, knowing that, we're going to do 2 examples. So if you want to divide the paper into halves, we're going to do example 1. So for example 1 and example 2, if you want to split your paper in half, I have 36x to the 4th minus 4x squared. So we're going to break it down. So 36, if you wanted to, you could make the factor tree. So if we do that off to the side, 36, that's going to be 12 and 3, 4 and 3, 2 and 2. Okay, so 36 is going to be 2 squared multiplied by 3 squared, and then we can put the 4 x's. 42 is going to be 6 and 7. That's a 2 and a 3, so it's going to be minus 2 times 3, and then x times another x. You can put dots between your x's. You don't have to because it's assumed that it's multiplication. So make sure you know how to do the factor tree to find these coefficients. Notice that these are the only coefficients. There's no other way. If you did the factor tree differently, you'd still end up with 2 squared, 3 squared, and 2 and 3. So my GCF, what factors do you see they have in common? Well, I see they have a 1, 2, they have 1, 3, and then they have 2 x's in total. So, wait, I missed a number. There's a 7 on there. I knew that was funky. Okay, there's a 7. So that's my GCF. So that means I'm going to factor out the 6x squared. But now here comes your exponent practice. So if I'm going to divide, because that's why I box this divides button, divides word. If I divide by a 2, a 3, an x, and an x, so 2 x's make 1, so they disappear. And 2 squared divided by 2 is just 2. 3 squared divided by 3 is just 3. So I'm left with 2 times 3, which is 6. And I'm left with 2 x's, so that'll be x squared. Okay. On the second term, if I divide this by 2, 3, x, and x, 1, 1, 1, 1, so I'm left with negative 7. So this is my factored form. It's now factors because I have two quantities that are being multiplied to make the original product. Original expression. And then if you want to, go back to your multiplying a monomial by polynomials and do that area model or do the rainbows or however you did it and multiply and distribute this back out. Do you get the original expression? If you do, then you're doing all right and you're hunky-dory and you did it right. But if you don't get the original expression, figure out what you did interesting. Factoring is awesome because you can check every single answer. All right, example 2. These keep rolling out of my way. Example 2 is a little longer, so 4x cubed y squared minus 20x squared y cubed plus 12xy to the 5th. So I want you to pause, try this on your own. All right, so 4, 20, and 12, I know they're even, so 2 goes into them, but 4 actually goes into them as well. So I'm going to have a common factor of a 4. Common factor of 4. How many x's do they have in common? Well, this is 3, 2, and 1, so they all have 1 because that's the minimum that is there. Y's are 2, 3, and 5, so y squared will be that. So if you don't recognize how this is the GCF, go back through and figure it out. So then if I divide by 4x y squareds make 1, 4 makes 1, and that is going to be x squared. Divide by 4xy squared. I'm left with 1y. Oh, it's a minus negative 5. Should do that first. I'm left with 1x and 1y. Divide again by 4xy squared. X's make 1s. That makes 3. Say positive 3, and I have 3 y's in the numerator. Boom. And again, you should be able to distribute this and get back that original expression at the top before we did any dividing. So divide out to find your factors that will multiply. And that is GCF. So woohoo! All right, going back to pulling out my PowerPoint. There we go. So again, why are x-intercepts such a big deal? Why are we headed this direction? What do you think factoring could do to help us find those x-intercepts? And think about also starting your brochure or your how-to blog on how you factor, because this is one step that we could use to factor expressions. All right, have a great day and thank you for watching. Bye.